Hey everybody, today I'll be going over learning target 12, which once again relates to derivatives, but this time more specifically using the product rule, the quotient rule, and the chain rule. So before we get into the actual problems, I was hoping we could do some review of what these rules are and what the different equations are used for them. So given that we have the product rule, we want to find the derivative of some function f of x. And f of x is the product of two functions. In this case, let's just call it h and g. So if I want to find the derivative, this will be equal to effectively the derivative of one function times the other plus the derivative of the other function times the original. So it sounds a little bit complex, but the way I like to think about it is we just have h of x times g prime of x plus h prime of x times g of x. And this can be either order, this can be flipped around as long as you have some original function times the other's derivative plus derivative times the other function, you're good. So you'll have a derivative times an original function plus another derivative times an original function. Quotient rule is a little bit more complicated. Just since we're dealing with division, it can be a bit of a pain. But the way I always was kind of taught was this is like called the high function, and this is like the low function. It's kind of a sing-songy way, but we learned that derivative was low d high minus high d low over low squared. So low is just the g of x. D high is the derivative of the high function, h of x. And then that's just kind of how we learned it in the original way. But from a standpoint of the equation, let's go through that. So we'll have low d high, so g of x times h prime of x minus high h of x, d low g prime of x, all over low squared, so g of x squared. This is something to just memorize. It's not super intuitive. Personally, I've never actually gone through the proof of how we get this, but this is something that we have and we need to memorize it and learn how to apply it. So whatever works for you to help memorize it, like I like the sing-songy way, low d high minus high d low over low squared. That helps me, but whatever works for you. And finally, the chain rule. The chain rule is probably the one that causes the most problems. Even still, I've taken what 5 or 6 math classes here at UVA, and the chain rule still makes me stop and think sometimes. So learning how to do it now effectively will definitely have pay some dividends out later. But we have some function h, and inside of h is another function g. So the way we will take the derivative of this is we'll have h prime with g of x still inside of it times g prime of x. This just means like we have some function inside the other inside of another function. Like the outside function, we take its derivative and leave whatever's inside of it, and then we multiply it by that something inside. But I have a few chances to try it out with those rules in mind. Let's solve some of these problems. So find the derivative, and first question I have a polynomial here times a trig thing here. And keyword there was times. So I'm looking at my rules, definitely not quotient rule. I don't see division. Chain rule, I don't really see a function inside another function, but product rule, it looks like a product rule to me. So let's just say that this is our h of x and this is our g of x. We'll have g prime of x, sorry, g prime of x equals the first function, so 2x squared minus 5x minus 3 times the derivative of the other function, and the derivative of cosine is negative sine, plus derivative of the first function. So using power rule here, we will have 4x minus 5. And that comes from taking that 2 out in front, subtracting 1. Same thing here. We have a 1 minus 1. If you have a little bit of trouble with this, I would go back to the last video, learning target 9. I go over the power rule a little bit more in depth. So that's a derivative of h of x, and we just multiply this by g of x. And just to make this look a little bit better, I don't like having like a negative coefficient just right in front there. So I'm going to rewrite this as 4x minus 5 times cosine of x minus, that's where that minus sign comes from, 2x squared minus 5x minus 3 times sine x. Yeah, that's pretty much simplified as it can be. Alrighty, on to part B. And the first thing I see is this division symbol, this fraction symbol. So I'm going to take a wild guess and say that it's the quotient rule. And here we have our high function, e to the x, and our low function, 2x squared plus x minus 4. So let's figure out this derivative, shall we? Using our quotient rule steps, the first thing, well, actually, let me add in. I think we've been calling this h of x and this g of x, just to match our quotient rule chart over there. First, we have g of x, so 2x squared plus x minus f times the derivative of the higher function, and the derivative of e to the x is just e to the x. Subtract that high value is also just e to the x, and the derivative of the low value, using power rule, we will have 4x plus 1. Then all of this will be over that lower function g of x, and that'll be squared. So 2x squared plus x minus 4 squared. And now what I'm going to do is I notice we have e to the x in two individual terms here. So I'm going to factor that out inside or in the numerator. So we'll have e to the x. And since that's factored out, we'll take whatever was inside both those sets of parentheses and then subtract them. So minus 4x minus 1. That comes from minus 4x minus 1. And all of this will be over that 2x squared plus x minus 4 squared. And simplifying by cleaning up that numerator just a little bit more, we will have e to the x, 2x squared, minus 3x minus 5. And then that denominator, there's really no way to clean that up. Squaring it would just make it so much more complicated than it has to be. So that is our answer there, using the quotient rule. Alrighty, I'm down to C, and let's think about what rule we could use. I don't see any multiplication happening. I don't see any division happening, but I do see a function inside of a function. I see this and I see this. So, let's identify our h of x and g of x. So when I look at this outside function, I'm seeing these parentheses and I'm seeing that 3. So the way I'm thinking about this is h of x is just something, let's just say u cubed. So where u is equal to, well, I guess negative u cubed, where u is equal to 4x minus 3ex plus 4. And we need to take a derivative now. So we know that it'll be the outside function, the derivative of the outside function with whatever's inside of it. So considering h of x here, that's a power rule. So that 3 goes in front. I subtract 1. So I will have negative 3. And then that 3 minus 1 is 2. And then what goes inside there is just what we had originally, that g of x or u value. So 4x minus 3e to the x plus 4. And now we need to multiply this by the derivative of the inner function, g prime of x, or I guess in the case I used earlier, u prime. And this, so that's the derivative of what's in here. And from that, we will get 4 minus 3 e to the x, because the derivative of e to the x is e to the x. And then as I really harped in the last video, the derivative of a constant is just 0. So this is our answer here for this chain rule question. All right, last problem here. This also looks to me like a chain rule problem. So g prime of t, we need to consider the derivative of the outside function and derivative of, derivative in terms of t of cosine of something, like say u, is just equal to negative sine of u. This is that u is a function of t times u prime. So considering that 9 is still there, we will have negative 9 sine, leaving this inside as the same. Now though, we need to consider the derivative of the inside function, which is, what was I calling it earlier? I was calling it g of x, or u in this case, to t to the 7/5. And that's power rules, that goes in front, and I subtract 1. So we're multiplying by 7/5 t, and then 7/5 minus 1 is 2/5. So that is our derivative there. This section is definitely more complex than like the power rule stuff. It's a core learning target, so it's really important you guys practice this and get it down. I hope this video with the questions and with the rules helps out. If it's not fully getting through, we have other resources on Canvas, and you can always come by office hours and get some extra help. But for the meantime, happy studying.